Hello again. This is an example of how to solve a bridges puzzle, starting with the first from this month's newsletter. In a bridges puzzle, we usually look first for either very small or very large numbers, and also look for things that are on the edges and corners. So one place we might start is this top left corner, where we need to put two bridges coming out of this island in the top left. Now, if they both went to the right, that would make this island happy and this island happy. But the problem is now we have nowhere else to go, and all the islands are going to have to be connected by bridges by the time we're done. So we can't have two that go to the right. So at least one of them has to go down. And because this is a 1 down here, we can't put two going down, so one has to go to the right. And now if we look at this puzzle, this island right here that has a 2 in it, one goes left, the other has to go down. So we have a start. Let's look down in the bottom left corner. This 2 can't go up anymore because the 1 is completely satisfied, so both have to go to the right. Now let's see what a 3 can tell us. This 3 can see two other islands. Because it's a 3 and not a 2, we have too many bridges for them to all go one direction. So we have to have at least one going in each direction. Likewise with this 3, has to have at least one going in both directions, and this one has to have at least one going in 3 directions, and this one also at least one in each direction. Let's see what other kinds of things we can discover. This 2 is very much like the one in the top right corner, but instead of looking at the top and seeing that we couldn't put both to the right, let's look at the left side first. So when the 2 goes down, it would hit a 1 island. So we don't know if it does that, but certainly if it does, or if it doesn't, either way we're going to have at least one left that has to go to the right. So we're going to draw that bridge in right there. Now let's look at this 3. We've already taken care of 2 of the bridges. There's one left, and there's only one direction for it to go. So it's going to go up. Oops. And that was an accident. And now this 1 suddenly is cut off from being able to be connected to this 3. Before it could have, but this bridge has cut that avenue off. So now the 1 has to go up. And that now has used up all the bridges for the 2. So now for the 4, we've got 2 left. Where could those go? Well, they can't both go down because this island needs 2 bridges, and one of them's already taken up. So at least one of them goes right. We could have also seen that by looking at the 3 and using the same 3 logic we've used before. Now, what do we have here? We have 2 sets of lines that need to be connected in some way. So if this 2 island were to connect upward, that'd be great. They'd both be connected. If it goes to the right, then this 1 will be satisfied, and now we have a little segregated network, and we can't have that. So it doesn't go to the right. It must go up. And now this 1 has nowhere to go but down. And now we can clean the rest of these up just by looking at what's left to do. This 3 can't go up anymore. It's got to go to the right. This one's done. This can't go down anymore, so it's got to go up. This can't go left anymore. It's got to go down. And there we have the complete solution.